Okay guys, let's take a look at today's lesson. What we're going to be looking at today are applications for conic sections. So we're going to do a couple of examples. These typically require a calculator. Hopefully you have yours with you today. So if you get your calculator out, for the most part we would use a calculator. So let's take a look at the first question. So number one, we have a doorway is in the shape of a semi-ellipse. Okay, so half of an ellipse, and then it gives us the dimensions. So it's 10 feet wide and 8 feet high. All right, so let's look at that. So we have 10 feet wide and 8 feet high. So that would be 8, and this distance right here would be 10. They want us to find the equation that would describe the ellipse. Okay, so let's look. We have this section right here is 5, and then we have this section is 8. So we can tell that actually this is our B, right? The smaller one. For an ellipse, the smaller one is B, and this would be A. A would be the 8. Okay, so what my preference to be would be to make the origin right here in the center. Do you have to? No. I mean, you can write the equation wherever you want to. We'll get the same answer, but it's just easier if we put the origin right here in the center. So if we think of it this way, we're superimposing the coordinate axes like that. Okay. All right, so that means that it's just going to be y squared over A is 8, so 64, plus x squared over 5, so 25 equals 1. Now, it typically kind of upsets students to have a full equation of ellipse there when we just have a semi-ellipse. If you were really upset by that, you could basically say that y has to be greater than or equal to 0. That would restrict to half of an ellipse if you wanted to do that. You don't have to, because when we use it, we will know that we're not going to get any negative y values, right? That would be down here, and those really don't exist on this. So it's not a requirement, but if it makes you more comfortable, you can certainly write that. Now it wants to know how high is the doorway 2 feet from the center. So we could go either way. So the center's here. We could go either way, 2 feet this way or 2 feet that way. I actually kind of prefer x to be positive, so I would look at where x is 2. And they want the height. So the height is going to be this distance right here, this y value. They want the y value is basically what they're asking for. So what we're going to do is we're going to substitute the 2 in for the x, and then we're just going to solve. So y squared over 64 plus 2 squared over 25 is 1. So y squared over 64 equals 1 minus 4/25. Alright, so y squared over 64 equals, let's see what, 25/25 minus 24/25 is 21/25. And then we would just multiply both sides by 64. And you know, we have use of a calculator, so at this point I would probably get my calculator out and multiply these numbers together and then square root them. And we know from our experience that that would generate a plus minus number, plus minus 7.332. But from this information up here, we can see that y, and plus it doesn't make any sense for a distance to be negative, right? So y is going to be the positive version. So it's basically 7.332 feet high. That location in the doorway is 7.332 feet high. Okay, how is that? Not too bad. Right, let's take a look at the next one. So we have two microphones 1 mile apart, record an explosion. Microphone A receives the sound 2 seconds before microphone B. Where did the explosion occur? All right, so what this is a classic kind of problem. Usually it involves, microphones or sound, usually, not always, where this is a hyperbola. This is actually talking about a hyperbola because there's a difference between when microphone A and microphone B hear the sound. So let me read to you the definition of a hyperbola. We talked about, as we went through the shapes, we talked about their definitions and how those could be used for word problems. So the difference of the distances from any point of the hyperbola to the two foci is the same. It's the same number. So I want us to investigate that for a moment. So let's say, so we have a hyperbola. Here's our focus points, right here and here. So if I were to say, look at this point, and I were to measure the distance here and here, I was to measure these two distances and subtract them. So this distance minus this distance, that's going to be the exact same number as if I'm here and I measure these two distances. This distance minus this distance is going to give me the exact same number. It gives me a constant. Now what's pretty significant for us is it actually gives us a specific constant that we can find. So I want to look at that. This distance right here between this point and this point, that's A, right? We're familiar with that. The distance between this, location and here, we know that's C. Okay, is everybody with me? Okay. So let's consider that the point that we're measuring is this vertex right here. We're going to look at this, and we want to see the difference in the distances. So I'm going to measure from, we're going to measure from here, from this vertex, from here to here. So this distance right here, I'm going to take that distance, and then I'm going to take this, let's just change the color so it's more. So here, this distance, and then I'm writing it on the outside so we can see a little bit better. This distance. Okay, so I'm going to find this distance. I'm going to find this distance, and I'm going to subtract these two distances. Okay, so let's think about that. Okay, so this part right here is A plus that little piece, right? And then I'm going to subtract this little piece. What does that leave me? 2A. That leaves me 2A. So that's the difference in the distances, is 2A. Always. It's always that same number. Okay? So the differences in distances equals 2A. And we just looked at why that was. With the most simple example, making the point be exactly at the vertex. That's the most simple example. Okay? All right. So that gives us our information that we need to be able to solve this. So we have two microphones 1 mile apart. They record an explosion. Microphone A receives the sound 2 seconds before microphone B. All right, so let's just consider that this is microphone A and this is microphone B. Now that also troubles students because we want to put the microphones at the vertices. We just really do. And that's understandable because really to us the vertex is like the most important part, right? That's where the hyperbola pieces are. But the focus is actually the most important part. The focus is where it's equidistant from all kind of things. That's where if you were want to put like a sound microphone or something, you would want to put it at the focus. You wouldn't want to put it at the vertex. So what's that saying is when they have a scenario like this, microphone A and microphone B, they're talking about A and B being at the focus points, not the vertices. All right, so we know that these two microphones are 1 mile apart. And microphone A receives the sound 2 seconds before microphone B. That is the difference. The difference in distances. I know it's sound, but they actually given us a conversion, sound into distance. So basically, 2A is going to be 1 mile apart, so 2 seconds. So the difference is 2 seconds. So A is going to be 1 second. Now time doesn't really help me when I'm dealing with distance, right? We need to use the conversion. So sound travels at 1100 feet per second. So A is basically 1100 feet. Okay, so we used that. We were able to get that by the information about when, the difference between when they hear that sound, when the two microphones hear the sound. Okay, so knowing that, we also know that this full distance right here is 1 mile from here to here between the two focus points is 1 mile. So what would that be? That would be 2c, right? C plus c, so 2c equals 1 mile. Now this is units, these units are feet, that unit is miles. We're going to have to convert one or the other. My preference would be to convert the mile to feet. It doesn't say, so you could go either way. So 1 mile is 5280 feet. So 2c equals 5280 feet. Okay, so that means C is half of 5280, which is 2640. Okay, and so what we're doing is we are building the pieces that we need to write the equation. We're going to write the equation of our hyperbola. Okay, so we have A, we have C. We're going to use our little helper equation. So 2640 squared equals 1100 squared plus B squared. So B squared is going to be a fairly large number, 57, 59, 600. You don't have to use commas. It's not necessary. I mean, you can if you want to. All right, so we're ready to write our equation. Now, I have this oriented along the x-axis. That was just my choice. It doesn't tell me. I could orient it along the y-axis just as well. We're going to get the same information. Doesn't really matter. It's whatever you want. I decided to orient it along the x-axis. So my fraction, the x fraction, is going to come first. So x squared over 1100 squared, which is 121, minus y squared over the 57, 59, 600 equals 1. Now, another thing that students get really kind of upset about is like, well, you just gave me a whole equation of a hyperbola. How do I know where the explosion occurred? If we were, say we were doing this calculation for someone that was trying to search for this, like on a search team or whatever, we would give them an area where it would be. That's what we would tell them. We would need more information to be able to narrow it down. The information that we have is the microphone A gets the sound first. So if this were microphone A, that would mean that the explosion would need to be on this branch of the hyperbola, right? We could kind of narrow it down for them. But if I said this is A, you might say that's A. So it would depend on how you drew it, right? It would depend on how you drew it as to what we would be able to tell them. So for the purposes of this question, we're just satisfied with the equation itself. And then, we would need more information to be able to narrow it down further, if that makes sense. Okay, we don't need to say, okay, it's the right side and we have to, take this and condense it. No, we're good where we are, okay, with the information that we have. Questions on that? Are we all right?